Welcome back to my YouTube channel, Square Solution. In this video, we will prove one of the standard integral formula and then we will solve some examples based on the formula. So now, we will see the formula of dx divided by root over x square minus a square. So here, we will substitute I equal to integration of dx divided by root over x square minus a square. Instead of x, we will put as a into sec theta. So now we'll differentiate x with respect to theta. So we can write dd theta of x, which is equal to dd theta of a, then sec theta. So here we can write as dx by d theta, which is equal, so a we can take out. So dd theta of sec theta, this one can be written as sec theta, then tan theta. So instead of dx, we can write as a, then sec theta, tan theta, then d theta. Now, instead of this integration I, now we can write as integration. So instead of dx, we can put as a sec theta, tan theta, d theta. And instead of x, we can put a sec theta. So therefore, integration I turn out to be integration, then a, then sec theta, then tan theta, d theta, divided by root over. So instead of x, we'll put by a sec theta. So since it is x square, we can write as a square, then sec square theta. So here we can write as a square. So this one can be written as a sec theta, then tan theta, d theta. So from here we can take common a square. This one we can write as a square, then sec square theta minus 1. We also know that sec square theta minus tan square theta, which is equal 1. So therefore, sec square theta minus 1 is equal tan square theta. So here, this one we can write as a, then sec theta, tan theta, then d theta, divided by, so instead of root a square, we can put as a, then sec square theta minus 1, we can put as tan square theta. So here we can write as tan square theta. So here a can be cancelled. So this root and square will go. Then this one we can write as integration sec theta, then tan theta, divided by tan theta, then d theta. Tan theta and tan theta we can cancel. And this one remains as sec theta, d theta. So the integration of sec theta, this one can be written as log of sec theta plus tan theta. After integration, let me mark as C. So the constant here, I'll put as C1. So when we look at this equation, x is equal a sec theta. So therefore, instead of sec theta, we can write as, instead of this one, we can write as x divided by a. And instead of tan theta, if we make use this formula, this one can be written as root over sec square theta minus 1. So therefore, this integration can be written as log of x divided by a plus root over sec square theta minus 1. After integration, we can put a constant c1. This one can be written as log of x by a plus root over, instead of sec square theta, I can put as x square a square minus 1 then plus c1. So when we simplify this one, we can write log of x by a plus root over, so x square, I will cross multiply this a square to this side. This one can be written as minus a square divided by a square plus c1. This one can be written as log, so here root of a square we can write as a, so log of x by a plus root over a square x square minus a square divided by a, so plus c1. This one can be written as log of x plus root over x square minus a square whole thing divided by a plus c1. Now we'll use the formula log a by b, which is equal to log a minus log b. This one can be written as log of x plus root over x square minus a square minus log of a plus c1. So this one can be written as, so since log of a is a constant, so log a, which is a constant, if we plus with c1, so minus log a plus c1 can be written as c. So log of x plus root over x square minus a square, and after integration we have to put a constant c. So this is the proof. So now let us solve this question number 1. So let I is equal integration e to the power x, then dx divided by root over e to the power x holding square minus 1. So now we'll substitute e to the power x by y. Now we'll differentiate ex. So ddx of ex, this one can be written as ddx of y. So here ddx of ex is ex, so this one is dy by dx. We'll cross multiply, we'll get ex dx, which is equal dy. So therefore in integration I, we can substitute ex dx by dy. So therefore integration I can be written as I equal integration dy, instead of ex I'll put by y, become y square minus 1. So 1 we can write as 1 square. So if we make use the standard integral formula, this one can be written as log of y plus root over y square minus 1 square. Then after integration we have to put a constant c. This one can be written as log. Instead of y, we'll put back by ex, then instead of y square we can put as e to the power x holding square minus 1. After integration we'll put a constant c. So now we'll go to question number 2. So let I equal dx divided by root over x plus 1 holding square minus 1. So here we'll substitute x plus 1 equal y. Then we'll differentiate x plus 1. So ddx of x plus 1 is equal ddx of y. So this one can be written as, so ddx of x is 1, ddx of 1 is 0. This one is equal dy by dx. This one can be written as dx is equal dy. So now we substitute the value of dx by dy as well as x plus 1 by y. So the integration I turn out to be I equal integration dy. Instead of x plus 1, we'll put by y, become y square minus 1. So once we can write as 1 square. So if we apply the standard integral formula, this one can be written as log of y plus root over y square minus 1. So after integration, we have to put a constant c. So now if we put back the value of y by x plus 1, so here we can write log of x plus 1 plus root over x plus 1 whole square minus 1. So then we have to put a constant c. So now we'll go to question number 3. In question number 3, we have to find this integration. So here, let I equal integration of dx divided by x, then root over log x whole square minus 4. So now we'll substitute log x, which is equal y. Then we will differentiate log x. So ddx of log x, this one can be written as ddx of y. So ddx of log x is 1 by x, which is equal to dy by dx. So if we simplify this one, we can write 1 by x dx, which is equal dy. So therefore, this integration I can be written as, instead of dx by x, we can write as dy. Instead of log x, we'll replace by y. So therefore, I is equal dy root over y square minus 4. This one can be written as dy divided by root over y square minus 2 square. This one, if we apply the standard integral formula, we can write as log y plus root over then y square minus 2 square. After integration, we have to put a constant c. So now instead of y, we'll put by log x. So here we can write as log x plus root over log x, then whole square minus 2 square become 4. After integration, you have to put constant c. So now we'll solve this question number 4. So here, let I is equal integration of cos x dx divided by root over sine square x minus 4. So here we'll substitute sine x by y. So now we'll differentiate sine x. This one can be written as ddx of sine x. So this one is equal to ddx of y. So ddx of cos x of sine x is cos x. This one is dy by dx. This one can be written as cos x dx, which is equal to dy. So therefore, if we substitute cos x dx by dy as well as sin x by y in the integration, so here we'll have I equal to integration of dy divided by root over y square minus 4. This one can be written as integration of dy divided by root over y square minus 2 square. This one can be written as log of y plus root over y square minus 2 square. After integration, we have to put a constant c. Now if we put back y by sin x, so here we can write sin x plus root over, instead of y, we can put as sin x. So here we can put sin square x minus 4. After integration, you have to put a constant c.